there's another really interesting feature about light called polarization, and polarization is something that is kind of a way that we can manipulate light based on some of its properties. And so what's going on is that light as a wave is vibrating in all directions. Okay, it's sending out this kind of radial wave. And if you were to create some type of grating that would block out waves traveling a certain direction, so like if you have this vertical grating, then the horizontal waves passing through it would get blocked out, and then only some of the light could pass through. Okay, and so if you only wanted the vertical moving light to pass through, then you would put a vertical polarizer in front of it, and that would prevent the light that's moving horizontally to pass through. Okay, and then you could actually block out all the light if you put a vertical filter and a horizontal filter in front of it at the same time. This is really useful because it's a way that you can take light and filter out light, and if you are able to control the direction of that light, then you can filter out the light that you want to. And the more modern 3D technology, right, actually like for watching like 3D movies, the glasses rely on like these polarization filters to block out the certain direction of light, so that only some light is getting to each eye. and that way it allows you to see something as if it was three-dimensional. And so here's a picture of water, and here's a picture of that same water with a polarizing filter. And so what a polarizing filter can do is kind of block out light from reflections. So like for this example, you can see into the water when without the filter you wouldn't be able to see because of all the light reflecting off of it. Now the reason you can do this is because when light reflects off of a surface, all that light becomes polarized in the same direction. And so what's happening here is the light is coming down and hitting the water. The light reflecting up towards the viewer is going to be reflected as horizontal light, moving side to side, because it would be kind of like parallel to the water. And so all the light's going to hit the water. Only horizontal light's going to bounce up to the person watching here. And if they apply a polarizing filter that's horizontal, they're going to clear out all that light that was reflecting, and then you can actually see into the water. And so this is polarized lenses. Like if you were to get sunglasses that are polarized, they're very popular for people who like to fish, because you can actually see the fish in the water better when you eliminate that glare. You also see them like if you someone who likes to go to the snow, there's a lot of glare coming off the snow, but all that light coming off the snow is polarized, and you can block it out with a polarizing filter if you have that polarized lenses on your sunglasses. And it's also good like for driving. So someone who drives a lot, it can prevent the glare from the road and the hood of their car, just kind of take the strain off of their eyes. So the question then is, of these 4 pairs of sunglasses, if you are driving a car, or so let's say you're going to the snow, or let's say you're trying to look into the water, which of these polarized sets of lenses would you want to be wearing? The answer is C, because C is going to block out all of that horizontal light. Okay. The second question I have, not written here, is if you're going to see a 3D movie, which kind of set of polarizing lenses would you want to use? The answer would be D, because they're polarized in different directions. And so what that allows the technology to do, or the camera to do, is to, or the I guess the projector to do, is to send out 2 different images, and the left lens will block out the horizontally polarized light, and the right lens would block out the vertically polarized light, and you would be seeing a different image in both eyes.